So let's go through the Unit 3 review answers from for your test. We're going to start by looking at those function families that we were looking at. Remember, quadratic is a parabola, so you can sketch that any way you want. Just have some shape that looks like that. Cube root is the one that has that sort of twist to it. The square root is the one that was kind of like a half. Looked like it was only half there. Absolute value should be a V. And then linear is just a line. And so when you're trying to find these, you're looking for the shape to match the parent function. Moving on, we're going to be filling in our tables and sketching the graph. So keep in mind, this means I do -2 squared minus 4. Don't forget to put the negative in parentheses before you square it. Otherwise, your calculator won't square the negative. It'll only square the 2. So -2 squared is 4, minus 4 is 0. Then I do -1 squared minus 4. -1 squared is 1, minus 4 is -3. 0 squared minus 4 is -4. Then 1 squared minus 4 is -3 again, and 2 squared minus 4 is 0 again. So I just plug those values in, not forgetting to put parentheses around the negatives. Then I'll plot these. So I do -2, 0, -1, -3, 0, -4, 1, -3, and 2, 0. And it is the shape of the quadratic that we did in the top. We call that a parabola. Some of you call it a U. Whatever you want to call it, that's the shape that we're looking for. Up next is a square root, so keep in mind when you're doing a square root, you'll plug that in your calculator if you need to, -1. Then hit equals before you subtract 2. But you'll find that when you plug this one in, it comes out as undefined. Or another thing you can do is put parentheses around that before you subtract 2. So this is how I would plug it in my calculator. Turn this on, clear, I would do second square root. It opens up a parenthesis for me. I put -1, end that parenthesis, and then -2. Now see what happens. Domain error. Domain error means that something's wrong with my input. Remember, the domain is the input. Something's wrong with my input. And that is that I can't plug a negative into a square root. You can't take a square root of a negative number. So there is no answer for this guy here. But then I'll do the next one. I would do second square root, 0, end that parenthesis, -2. Oops. Get my answer, -2. Then I do the square root of 1. Square root of 1 minus 2. Square root of 1 is 1. 1 minus 2 is -1. Square root of 4 minus 2. Some of you might not need to use your calculator, but if you do, square root of 4 is 2. 2 minus 2 is 0. And then the square root of 9 minus 2. Square root of 9 is 3. 3 minus 2 is 1. And so when I plug that, or put all those points in, I get 0, -2, 1, -1, 4, 0, and 9, 1. And so there's that little half a graph almost that we're looking at. So that shape is that sort of half. I don't know what we call it. Some people called it like a bridge, and some people half of a bridge or half, but it's just that sort of half of a U kind of thing, or half of a sideways U, I should say. All right, moving on. If you need to pause, go ahead and pause. Moving on. We are going to be evaluating. Please make sure that you write these as ordered pairs. So this means I'm going to plug 6 in. F of 6 is 6 squared plus 10, which is 36 plus 10, or 46. So that is 6 comma 46. My input produced an output of 46. My input of 6 produced an output of 46. Now remember, it's different when I see it like this. This means that the function equals -8. So I want to find what's going to make 3x plus 4 equal -8. And then I'll have to go back into my days of solving equations to do that. So, and input of 4 would do an output of -8. Keep in mind the input-output position is important. X is my input. It goes in the X position of the coordinate. I want to find out when f of x equals 2. When is the square root of x plus 5 going to equal 2? Well, the easiest way for me to do that is to figure out what would be under here to get an output of 2. So the square root of what is 2, and the square root of 4 is 2. That means this in here must be 4. So I say x plus 5 equals 4. So I'll subtract 5, and I get -1. So again, an input of -1 would produce an output of 2. Don't forget to do your ordered pairs. And then lastly, this is an input because it's inside the parentheses here, and so that means it goes in for x. So f of -4 is the absolute value of -4 minus 3, which is the absolute value of -7, which is +7 because we've talked about absolute values. So this is, if I have an input of -4, my output is +7. Again, if you need to pause the video and take a look at it, slow down, whatever, ask some questions, do it. Otherwise, we're going to move on. We're deciding if these are functions, not a function. So remember that the input can only go to one output. So A goes to Milky Way, and then later on, A goes to Milky Way again, and A goes to Milky Way. So A is good. B goes to Snicker. I have no other B's. C goes to Snickers, and then all of a sudden later on, C goes to Twix. That's where I fail, right here in that C. That blew it. So this is not a function because C has two different outputs. When it comes to a graph, I find those a lot easier to find. Not that that's terribly difficult, but I find the graphs a lot easier because I can just do the vertical line test. Draw a whole bunch of vertical lines, and if it crosses that picture, not the coordinate plane, but the picture on the coordinate plane more than once, it is not a function, but this one doesn't. So this is, yes, a function. It passes. I do the vertical line test, the VLT. This one, however, fails. Do you see what I mean? If I draw a vertical line, it crosses through twice. It hits the picture twice. So this is not a function. This fails the vertical line test. Now, what's the big difference between domain and range? Domain is the input. The range is the output. Another way we can talk about this is domain goes from left to right, and output, the range goes from low to high. Okay, so keep that in mind when you're describing the difference between domain and range. Moving on. Now I'm going to find the domain and range, and so I usually like to do some highlighter on this. Remember, I go furthest left to furthest right. This one's got an arrow on it, and then I follow the X value. So this is 1, 2, 3 to the left of center. So that goes from -3 to infinity. We have a parenthesis around infinity. Now when it comes to the range, I do from the low, and it's low to high, has an arrow on the top end there. And so when I follow along the low end, that crosses at -1 and goes to positive infinity as well. Is this a function? Yes, it is. Passes the vertical line test. Up next, I'm going to do my domain from left. I want to try and encompass the whole picture to right. And then I'm reading where my yellow line crosses the axis. And so this is 1, 2, 3, 4, 5, 6 to the left of center. So that goes from -6 to 1, 2, 3, 4 on the right. And then I'll do the low and high. So low and high. And so on the bottom here, it is 1, 2, 3, 4, 5, 6, 7, 8 units below, and 1, 2, 3, 4 units above. Is this a function? Yes, passes the vertical line test. Okay, up next we're doing our simplifying. So we have to remember our power rules. Keep in mind that you multiply the regular numbers, and then the powers you put together, matching variables, and you can add the powers. Also remember that if you don't see a power on it, it's a first power. So I have 15x to the fourth, y to the third. On a problem like this is 4 to the first power. I'm going to multiply that power through. Power on a power is multiply. Like bases, I add. So this would be 4 to the 1 times 2 power. Not that that really matters, that order. X to the negative 3 times 2 power. So this is 4 squared x to the negative 6th. I don't like the negative power, so I'll bring that down to the bottom. So it would be 16 over x to the 6th. So I did 4 squared, that stayed up on top. And then x to the negative 6 moved down to the bottom and became positive. All right, when we have numbers and letters on the top and on the bottom, keep in mind again that the numbers we treat a little differently. That's 18 over 3. What can I divide them both by? I can take a 3 out, so that's 6 over 1. But then the letters are different, and I always look at what I have and where are there more and how many more. We've talked about that in class a couple times. Where are there more? How many more? So when I look at the x's, there are 5 more on the bottom. That means my x's are going to remain on the bottom, and there are 5 more. On the top, negative 1 is bigger than negative 5. In fact, it's 4 more than negative 5, so there are 4 y's on the top. And then the numbers that I had before, that 18 thirds, the 6 is going to go up on the top. I can put 1 on the bottom, but I don't need to write that because 1 times anything is that thing anyways. And then we had some expressions in radical form. That is a square root. So this is 10, the square root of 10 to the first power, or I just write this as the square root of 10. This one is the 7th root of 3 squared. So the 7th root of 3 squared would be how I'd write that one. 7th root of 3 squared. Now if I want to write it in exponential form, remember that there's a little 2 there because we don't have to write it on the square. So this is 9, the root in the denominator, the power in the numerator. So 9 to the 3 halves. This next one is 2 to the 7 thirds, the root in the denominator, the power in the numerator. So if I had to evaluate this guy here, I could evaluate it in either form. It doesn't matter. Some people prefer to evaluate it in this form because that would be the square root of 9 is 3 cubed. 3 cubed is 27. So if you're asked to evaluate, that would be how you'd do it. You could work your way through. Some of you might even just use your calculator and raise it to that fraction power. Again, if you need to pause, pause. Otherwise, here's our next up. I have to simplify this. So power out of power, it doesn't matter that that's a fraction. I can just go ahead and multiply those together. X to the 4 times 1/2 power. 1/2 of 4 is 2, so that's x squared. We just talked about this one. This is the square root of 9 cubed. That was the same problem we had on the previous page. So the square root of 9 is 3. 3 cubed is 27. And then I have some solving or some simplifying with the distributive property. A lot of times we use the box method when they're the double ones like this, and so I put that on the side, 4 and x, 3x and 1. I get 12x and 4, 3x squared. Sheesh, what is wrong with me? 3x squared and x. And then I look for like terms. Here's my like terms. That's 13x for those. Remember, that's 1x, so 12x plus 1x. So my simplified form is 3x squared highest power plus 13x plus 4. So let's do another box. 2 by 2 I draw it. I do 3x minus 2y, x and y, 3x squared, 3xy, negative 2xy, negative 2y squared. And so now I look for any like terms. It looks like I have some right here. negative 2xy and 3xy. Negative 2 plus 3 is 1xy, but again, remember, I don't have to write the 1. So when I write this, I have 3x squared plus xy minus 2y squared as my final answer. You don't have to always use the box method, and sometimes when the numbers are just like this, you can just go ahead and distribute that. So this is negative 3 times 2, negative 6x squared, negative 3 times 5 minus 15x, or sometimes people write it as plus negative, but I prefer to write it as minus. So that's the distributive property. Sometimes I like to go ahead and distribute that instead of doing the box method when it's just one term times 2, a monomial times a binomial. Up next, I've got a 2 by 3. I'm going to use the box method for this guy as well. So 3p plus 4 goes on the side. P squared minus 2p minus 3 goes along the top. And then I'll go ahead and multiply 3p cubed minus 6p squared minus 9p. And I go on the bottom and do that row. 4p squared minus 8p minus 12. I look on the diagonals, see what I can combine. 4 plus negative 6 is negative 2p squared. Negative 8 plus negative 9 is negative 17p. So when I write them all together, I get 3p cubed minus 2p squared minus 17p minus 12. Final answer. And then lastly, we have some solving that you're going to have to do. So there's a few equations that you're going to want to work through. If I have distributive property, I usually just distribute that right through right away. So that's 6x minus 10 equals 2. And then I'll go ahead and solve. Remember how we solve. Undo the addition and subtraction first. So 6x equals 12. Divide by 6, divide by 6, x is 2. Final answer for that. Another distributive property, multiply it through. 3x minus 3 equals x plus 15. When I have variables on both sides, I usually try to get rid of the smaller one first. That's not always going to work for me, but when it works, that's my technique. So 3x, remember this is like minus 1x, so that's 2x. That's like 1x there. Minus 3 equals 15, and then I have a regular equation. Add 3, 2x equals 18, divide by 2, divide by 2, x equals 9. Again, if you need to pause to get caught up, pause to get caught up. But then we'll finish our last problems. We've got a couple absolute value problems, as well as one where we have a double distribute. So here we go. I'm going to do the box method for this first piece here. X plus 2, 3x plus 8, multiply. Look diagonal. So I did x times 3x, 3x squared, x times 8, 8x, 2 times 3x, 6x, 2 times 8, 16. On the diagonal, I get 14x. So this is, that side of it is 3x squared plus 14x plus 16. Now I'll bring down that other side. 3x squared plus 2x minus 8. When we're working on these now with the squareds in it, it's always going to be the same, but that's not, remember, that's not going to be the case forever, but it is now. So the 3x squareds can cancel out. I have the same thing on both sides, and I'm down to a more reasonable looking equation. So I'll subtract the smaller of the x terms. Negative 8 equals 12x plus 16. I ran out of room, so I'm going to bring that over. Negative 8 equals 12x plus 16. I'll subtract the 16. So negative 24 equals 12x. Divide by 12, divide by 12, and negative 2 is x for that one. All right, keep in mind when we have absolute values, remember the absolute value adds to it. What's in here could be positive 9 or it could be negative 9. So I have two equations. X plus 2 is positive 9 or x plus 2 is negative 9. Move that over so you can see. And then I solve just like normal. I just have double the work. So I subtracted 2 on both sides in both equations. I got one solution to be 7, the other solution to be negative 11. When you see these in multiple choice format, usually they list it as a set of numbers from smallest to greatest, so that's set notation. The set of answers here is negative 11 and 7. So now we're down to 2 problems left. That's it. Just to kind of go through again, if you need to pause the video, pause it, look back, go see what you work your way through it. And so I'm going to set this up as either positive 8 or negative 8. So 2x minus 1 is positive 8, or 2x minus 1 is negative 8. Add 1, 2x equals 9. When it doesn't go in evenly, I can just leave it as that improper fraction. If I can reduce it, I reduce it, but I just usually leave it as an improper fraction. And I'm going to go through the same process on the other side. Add 1, 2x equals negative 7, divide by 2, divide by 2. X is negative 7 halves. Hopefully you recognize in 32 that we have an issue. You can't take an absolute value of something and get a negative number, so this one is a no solution. All right, what I'd like you to do is make sure you are comfortable with this material, prep for your test, be ready for your test tomorrow. You can use this review when you take your test, so keep that in mind. And if you have any questions, you can either email me or find a teacher to ask. Good luck.